Now that we discussed what are the Bayesian networks and how can they help us and why I want to use them, let's finally jump into the code and build it. Here, what I have is a README file. Let's start slow, but basically that README file sits in my Git repository that is available for you to test it out and see what's going on. What I have inside of that repository is pretty much what I explained in the architecture video of this series, but roughly what we have, just to repeat myself, is I have a list of experts over here, and for my example I introduced only the CI/CD, data protection, IAM, monitoring, networking, platform, and the secrets expert for now, but it can be both expanded or shrinked up to the taste, and we will configure those experts as we will go forward. On top of that, I added a couple of scenarios just for the simplicity of the demo, and we will go through all of that in a moment. And then another interesting file that we have is the incident model over here. That is what I call the security architect. And the naming is a little bit off here, but it is work in progress and just a proof of concept. Now, for the main code, what we have is that a Python application, and the thing that is used everywhere is pgmpy, and more specifically the DiscreteBayesianNetwork. That is bread and butter, and I'm very happy that this package exists and we can reuse it, and that's pretty much what I did. So my code base itself, how it is structured, is that we have the main py, which is the entry point for the application. It will receive the evidence, and in my case, I am feeding those scenarios, so it is a coded input of the application. Then it will read all of the experts from the folder, and based on those experts it will build the first layer of the Bayesian network, and from the first layer of that network it will infer certain risks, and based on those risks it will build a second Bayesian network that will be controlled by the incident model itself. And from that network, it will infer and do the calculation for the incidents. What are the probability of a specific incident occurring? Now, all of that looks nice and clean, but let's dive a little bit deeper into the implementation and what we have in experts, for example. The experts file is a kind of small one, but it gives an idea. And the idea is that each expert is responsible for one slice of security. And for example, the CI/CD expert is responsible for the CI/CD security and CI/CD nodes. For example, here we have the pipelines, CI/CD pipelines that they should exist. That's one of the controls. Next, the last one is that from those pipelines, we want to have signed artifacts as an output, and those signed artifacts would be used later on for the system itself. In terms of risks, this expert is responsible for just a generic CI/CD risk that is not actually used right now, but two more of a little bit of better that are easier to understand are the dependency risk, meaning that there might be a risk about the dependencies. It might be both dependencies that are created by the platform itself or some third-party dependencies. So, for example, if we don't have SBOM, or if we don't have the security scanning in the CI/CD, then it is very likely that there would be a dependency risk, because we just don't know if something broken being used to build our beautiful platform. And because of that, there might be that dependency risk. And based on that dependency risk, you might very well end up with an incident of, well, at the very least, just unavailable data platform up to the data loss. And another risk that is possible is just a CI/CD compromise risk itself, where your pipeline might be compromised and then you don't control your platform anymore. Now, from those nodes, we can build the CPDs. CPDs, it stands for the conditional probability distribution, and it is pretty much our DAG, so the directed acyclic graph. We have here a number of nodes that are control nodes, and they just basically the prior nodes from which we can infer others. And those others are the CPT nodes. CPT stands for the conditional probability table, and they have evidence and values. The evidence are the nodes that this one depends on. So this is the end result of my expert, and based on those evidence, and we can calculate the values. If the change management control is not implemented, so it is set to false or 0, and the CI/CD pipeline exists control set to 0 as well, then we can infer that the probability of this operational risk being false is 0.05%. So it is very unlikely that this risk doesn't exist. And at the same time, if both of those are true, that means that the probability of this risk being not valid is quite likely. The probability of this risk being false is 0.95. At the same time, the probability of this risk being true, so that the risk does exist, with both of those control being 0, not implemented, is 0.95, which is high, and the vice versa, the probability of this risk being true when both of those controls implemented is 0.05, which is low. I used those values from the top of my head, or to be more specific, from the top of ChatGPT's head and Cloud Code head and the Gemini. I used many models to generate those values, to estimate them and combine them into those tables. But it was fun. And I have similar type of experts for data protection. In here it is a little bit less meaty, but basically there are controls like data encryption is in place or data classification is implemented, and based on those we can infer what is a data exposure risk. The numbers are pretty similar all the time, but it just for the demo purposes. Now, after all of those experts are defined, we can understand how the security architect will work. It will read all of those experts, and from those experts it will understand what are the available risks that those experts can raise. And based on those experts, it will try to create, once again, in the CPDs and CPT type of language, so the probability tables and probability distribution, we are going to create the incidents or probability of those incidents happening. For example, we have the data exfiltration incident, and it relies on the credential theft risk. If someone can steal your credentials and use them to log into your databases, that means that the data exfiltration is quite likely. But at the same time, you need to have the data exposure risk and not to be able to find that someone is trying to steal your data. So with all of those three together, we can try and calculate the probability of data exfiltration being true or being false. Same as with risks, but on a higher level. And I have only a couple of those incidents, so they are announced over here as targets, and based on them we can see what will happen. Now, on top of that, for the simplicity, I added the dictionary, which is not full yet, but basically it is possible to use the IAM-MFA enforced as a name of the control that can be implemented or not implemented. But on top of that, it has some aliases like MFA, 2MFA, 2FA, multi-factor, and so on. And it would be possible in my scenarios, which are here, to use all of those. For each of the scenarios, I just added some description and the numbers that actually don't use it, are not used at all. And based on the evidence that is provided over here, we can calculate what are the risks and so on. So let's try it. And to try it, it is as easy as just to run the main Py code with a scenario of being number 1. When you start it, it will calculate it, it will run it a couple of times, and it will output that from our expert's output, expert results, we have that the CI/CD expert raised those risks, and the probability of the operational error risk is quite high, 0.95%, because as you can see, from the evidence, we have nothing at all in regards to the CI/CD. So the expert doesn't know if there is a CI/CD pipelines exist at all, if they have any sort of scanning inside of them, if are there any gates, and so on. Because of that, the expert assumed, and that is hard-coded into the code, that if control is not implemented, it means that it is not implemented. And therefore, the risk is more likely to happen. Then we have the data protection expert, once again screaming that the data exposure risk is quite possible, but the interesting bit over here is what I tried to control, is that the unauthorized access incident is not that likely. And for that incident, we control the IAM expert inputs plus the network inputs. And if we would go to IAM over here, here it is, we will see that the credential theft risk is actually quite low, because we have the two-factor authentication, and each account is individually assigned, and then on top of that, for each of the accounts that does exist in this platform, theoretical one, they have a very strict number of permissions assigned to them, and on top of that, their admin account, they are separated. Plus, on top of that, from the network perspective, we have separate network segments for each of their environments, and there is no public access to the data platform from outside. Basically, it's like a good security posture from the network perspective and IAM perspective. Because of that, the IAM expert says that everything is good, the risk is very low on both ends, and the network expert is happy as well, and the network intrusion risk is very low. Because of that, the incident level results from the security expert, from the security architect, would become like so, and the unauthorized access is still not nothing, because you can never have 0% incident likelihood, but at least it is a small number. Once again, those numbers are just pretty random, maybe from the top of my head, and they follow the common sense, but not necessarily polished. Still, those numbers can be used for the estimation, and based on those controls, we have that the unauthorized access is not that likely. At the same time, the supply chain compromise is very likely. And as a last last line in that output, I actually tried to find what is the most likely incident to happen, and in that case, it would be the supply chain compromise. And for that incident, I'm trying to find which control are the most impactful. So in that case, it was estimated that the dependency scanning would be very helpful, and it would reduce the likelihood of the supply chain compromise incident itself to 0.60, so 60% chance that this will happen. And that is actually my second scenario. Here everything is roughly the same as it was, but the difference is that the IAM is not as good as it was before, but still the network is solid. Some of the controls around roles are in place, but on top of that the dependency scanning is implemented. So if we would rerun this with number 2, it will change some of the numbers. So the supply chain is now, as promised, would be 0.60, and that is a good thing about the Bayesian network. As I was explaining in the previous videos, if you supplied the same input, it will answer you with the same question. So those are very definite and not randomized, which is good from the security point of view. You don't want to be unsure about your results, I guess. And at the same time, the unauthorized access incident goes up. So if multi-factor authentication is not available and there is a possibility that people would use shared accounts, that means that the unauthorized access itself is very likely. And now the most critical incidents that can happen, or the most likely, is a data exfiltration. And now it is just suggests us to use IAM MFA enforced to be implemented. We can change that and set it to 1 to follow its suggestion and rerun that same scenario. And in that case, it will reduce the unauthorized access back to almost 20%, but in addition to that, the data exfiltration goes down to 50% compared to 80, which is much better. There is one additional scenario, scenario number 3, and in here I showed that it is also possible to change the weights of those experts. With that weight overrides section of the input, we can say that I am actually only interested in IAM expert and what is happening with this one. And here I'm just using that MFA is implemented, CI/CD pipeline exists, but nothing else. And if we will run this, if we will run this scenario, then it will say that the final risk is 90%, and that is a combined risk across all of the experts, but not the incident. So this is somewhat of an average across all of those experts, what would be the likelihood of a risk happening. And the interesting bit is that here we have CI/CD risks being estimated as 55, 95, 95, but the weight of it is 0. And if we will scroll up, we will see that by default, and in each of the experts, it is a default weight is 0.5, so they all equally weighted. But in this case, I'm saying that IAM expert is much more important, and in that case, it calculated that the final risk is 0.9, and in here, that is the only one. It is basically that this expert says that the highest risk is a privilege escalation risk across those that he is aware of, and that risk has a likelihood of 90%, and because these are the only experts that meaningful for us, the final risk would be 90%. This bit was to be able to change how experts would contribute to the overall final risk score, but not necessarily would affect the incident level, at least yet. At least not for now. Maybe that will be changed, maybe not. So I will try to implement and use this small application in my skill for the next step. and to add some clarification what to do, how to implement those controls using LLM, and that would be fun. So stay tuned.